All right. So good on you guys for showing up this morning. A little bit sparse here. I wonder why. So I'll go through some housekeeping stuff before we get started with material. So we're going to start with module 2 this week. Something I posted an announcement after class last week. I've still got some emails, so if I haven't responded to you, I'll try to kind of work through those later today. I know there was an issue on module 2. I believe it was question 2.4. So even if you got it right, it was telling you got it incorrect, even though it was awarding the full points, right? So I'll go through, I'll make sure everyone's getting full points for that question as long as you submit an answer. It should already be treating that as they giving everyone full credit, at least when I look at it, it looks like it is, but it might still show you that it says like incorrect on the problem, okay? So I don't know if we'll quite get to that material today. If not, I'll touch on that on Thursday, and we'll have a better understanding of why that question was bugged. But as long as you submitted something on that question, everyone will get full points. Once again, I'll check on the back end. Now that due date is passed, everyone is receiving full credit for that, but you should just, for whatever reason, it's kind of displaying incorrect no matter what the answer you submit is, okay? So if you have a question on that, once again, should be kind of resolved. Everyone should see kind of full points for question 2.4. I'll make sure everyone's getting that. I'll get back to my office today. Other than that, so that's a kind of a good first thing, showing you that if I have to kind of convey some information to you outside of class, I'll use the Canvas announcements, right? So if you have a question, always make sure you're looking at the most recent announcements. Maybe I've already addressed it, okay? The other thing I posted here, since we had Martin Luther King Day yesterday, I didn't have office hours. I kind of posted that my office hours were canceled, and I'll be moving some of those office hours. So usually I have office hours 9:30 to 12:30. I'll get an announcement up later today. I'm going to finalize exactly when they're going to be. I'm going to add some additional office hours to replace Mondays on Wednesday and Friday this week. Okay? The exact times, once again, I'm waiting on a few emails, but I should have that probably posted by 1 o'clock today, exactly what those additional office hours will be. Like I said, some of them will be on Monday and some of them will be on Friday. So I split them up between the 2 days. Okay. Other than that, the other thing that I will get posted up under the files tab, and I'll just kind of drag and drop it right under files. It won't be any and under any subfolders, is I've got, if I can get this to, there we go. There we go. I've got kind of those CL times. So after kind of talking to my leaders, there's going to be a couple time slots where there aren't free locations. There's only 2 on Thursdays, I believe. And then I think there's 2 time slots on Monday, where instead of 3 locations, there'll be 4. So there'll be a few more time slots available on Monday than there are on Thursday. I'm going to get you all sorted based off of your preferences. And I'll also post a file that kind of says like CL session assignments. Your name will appear under one of those daytime locations. That does not mean that's the only one you can attend for points. You can attend any of them. Tried to reiterate this last week. It's the way for you to sort. I can guarantee you there will be a seat available during that time for you. But CL sessions start this Thursday. So I'll mention this again in Thursday's class. You can attend any daytime location that works for you, and you receive extra credit for that week. So for this week, module 2, if you attend one of the sessions on this Thursday or next Monday, you'll receive that extra credit. Okay. You'll sign in at the beginning of the CL sessions, sign out at the end. That's how kind of attendance is recorded. They'll then log that in a shared file. I then kind of try to upload those about every week or so onto Canvas, so you can kind of see kind of your running total of what your kind of CL attendance is. So you'll see those files kind of pop up later today. Once again, I think I've already got, in fact, if we go to the home page under module 2, yeah, so I didn't post it yet. I'll post it right here, kind of what those final days and times are. They aren't kind of the typical that I had mentioned, in the sense there aren't 3 at exactly every single time slot, but there's at the very least 2, right? Other than that, got all of module 2's materials up here. I'll try to start organizing my Canvas page. It looks like this. We'll have our materials for the week. You'll kind of have those practice problems, and you won't be able to see the quiz yet because that's not released until after class on Thursday. or kind of those practice problems associated with that quiz. Kind of put those under like what looks like a subheading there, just to kind of try to organize these files for you. Any of these files can always be found not just on the home page, but if we go to module 2, I'll just kind of drag and drop all of them under module 2 materials. So you can always find them on the home page or in the files. Okay. Any questions for me before we kind of get going here? So I also had a couple people reach out. If you have questions over old quiz questions, I can try to address those or respond to your emails. But those are also a good time to kind of come to office hours to get any further clarification you need on those. We likely won't spend class time reviewing old quiz questions. Once again, I can try to get you an answer via email, or if you want to review those, you can always stop by office hours the following week, kind of review those. Okay. Other than that, I think that should take care of everything. Unless there's any questions for me, we'll kind of dive into material here. Okay, so we'll kind of pull open this module 2 slides. I gave you the skeleton slides. I've got a few things in my version that might not be up in yours. We'll also do a lot of work on the dot cam. I think it might be nice today because we're a little bit scarce in attendance. I'll probably record what I do in the dot cam today. But moving forward, you have to be in class to get whatever I'm doing on the dot cam. So where are we kind of starting out? So we're going to start, this is probably about as macroeconomics as we'll get throughout the entire semester. So we'll start talking about something called the production possibilities curve, or I'll sometimes refer to this, or you'll see this in other resources, as the production possibilities frontier. Okay, so kind of the base model is, let's say we've got an economy, right? Now this could be a country, this could be the world, this could even be a state, this could also be a county, right? This could be even one firm, right? So it can be macro, but it can also be very micro, right? So we talked last week, what's the main problem in economics? We face a scarce resource, and we need to know how to allocate that to be the most efficient. So let's say I've got an economy and they've got 50,000 labor hours. That's their scarce resource, right? They're workers, right? So they're making 2 goods. I've got what? Computers and produce here. So any agricultural product, you kind of think about any economy faces, do I put money into tech goods, or kind of do I feed my people? Right? At this very, very core. Okay. So let's say I had something like this. I've got 50,000 labor hours, and every computer is going to require 100 of those. Right. So they're a little more labor intensive. Every, what did I say, ton of wheat. So that's my agricultural product I chose. Every ton of wheat is going to cost me 10 labor hours. So if I have 50,000 labor hours, I'm only producing computers. How would I determine how many computers I can produce? Each one costs me 100 labor hours. I've got 50,000 labor hours. I would take 50,000 and divided by 100, right? So if I do that, I get what? 500 computers. I'm only producing computers here. I haven't produced any wheat yet. As soon as I start to kind of change that production, let's say I was only producing wheat. How would I come up with the total amount of wheat I can produce? 50,000 labor hours. Each ton of wheat costs me 10. 50,000 divided by 10. Right? So we're thinking about, and here actually, let me switch this over so I can record this. Switch the video to here. There we go. And then you guys, I want you to see this. Okay. So what am I really doing here? I'm thinking about, there's 2 goods, right? This is where I want to make sure I line this up with the slides. I believe, okay, it doesn't really matter. We can do this either way. But let's say I was doing, let's put wheat on our y-axis, and let's put PCs or personal computers on our x-axis. Okay. We said if I'm only producing computers, how many can I produce? Well, we took that total number of labor hours and we divided it by how much each computer was costing us. So that gave us a total of 500 computers. If I'm only producing wheat, we said I would take the total number of labor hours, dividing it by how much each ton of wheat cost me, and I get what? 5,000 tons of wheat there. So our production possibilities curve for today, we'll start out simple. Next class, we'll kind of throw an additional wrinkle to this. But I don't just have to produce wheat, or I don't just have to produce computers. I can start to produce any point in between. Okay. So let's just, for the sake of one of these points, let's think about if I wanted to produce the first 100 computers. Okay, how many labor hours is that going to cost me? Well, if the cost of a computer is 100 labor hours, and I want 100 of them, right? The total cost would be what? Or sorry, there we go. 10,000 labor hours. So if I'm producing computers, what do I have to stop producing? The other good. So if I want 100 computers, that's going to cost me a total of 10,000 labor hours. How many tons of wheat do I have to give up? I have to give up 10,000 labor hours. Each ton of wheat is costing me 10 of them. How many labor hours did I have, or sorry, how many tons of wheat did I have to give up? 10,000 divided by 10, right? Or I had to give up 1,000, right? So I'd be left here at 4,000, okay? So this combination of wheat and computers is something I could produce, right? So when I start to produce computers, I have to give up producing wheat. Essentially, the cost of a computer is going to be in terms of what? The other good, right? To get those first 100 computers, I had to give up 1,000 tons of wheat. Or you can kind of think about, as I'm doing something with my resources, there's always going to be an opportunity cost, right? To produce more computers, I have to stop producing some of the other good. So this production possibilities curve is going to tell me all these different combinations of these two goods that I could produce using all of my resources. So any point on that curve, I'm using all 50,000 labor hours to produce some combination of these two. Now the extremes are kind of easy to figure out, right? Because I'm only producing one good. I take the number of labor hours of the resources I have, dividing by how many of those resources it takes to produce one unit of that good. So if I'm looking at this, I've got all these different possible points. I think on the slides, I just did 5 of these. So you can kind of work this out. We just did the first one, right? Where if I want 100 computers, I had to give up 1,000 tons of wheat. So I had this point of 104,000. I could then say if I want 250 computers, and I could do the same process to figure out, oh, I would then have to give up 2,500 tons of wheat, and I'd be left with just 2,500. And so I gave you 5 points here, but we could find any point on that curve, right, using that same process. Okay. Any questions on that idea before we keep moving here? So let's try to use a little intuition before we get kind of to the math side of it. If every computer cost me 100 labor hours, and every ton of wheat costs me 10. If I want one more computer every single time, how many tons of wheat am I going to have to give up? Computer takes 100. Ton of wheat costs me 10. 100 divided by 10, I'd have to give up 10 tons of wheat every single time. So if instead I was even thinking about, we could get as, fine of a point as one. If I want that first computer, we just said we'd have to give up 10 tons of wheat, I'd be at where? Well, if I gave up 10 tons of wheat, I'd be at what? 4,990? And I could do that for any point that I was interested in. So the slope of our production possibilities curve is going to tell us what? Well, how do you calculate a slope? Like if I had a line that's y is equal to mx plus b, right? The slope will always be what? The change in y over the change in x. So here I can think about the easiest way to find this slope is to move between the two extremes. Now I could find the slope if I had any 2 points on that line, and hopefully if I'm doing my math correctly, I find the same value. So if I use the extreme points, if I go from here to here, what's the change in y? I'm going from 5,000 to 0, so the change in y is, if I go from 5,000 to 0, I'm going down by 5,000. What's the change in x? I'm going from 0 to 500, so the change in x would be 500. So what's always going to be true? As I start to produce more of the x-axis good, I have to give up some of the y-axis good. So my slope is always going to be negative, right? There's an opportunity cost. When I produce one good, I have to stop producing something else. So notice here we end up with a slope of -10, or sure enough, what did we just say before this? Every computer was going to cost me 10 tons of wheat. So what this slope will represent is always going to be the cost of whatever your x-axis good is. Okay. So the slope of this production possibilities curve essentially tells me every time I want to produce one more of this x-axis good, this is how much of the y-axis good I'm going to have to give up, right? Or this is essentially my opportunity cost of producing one more of the x-axis good. Now I could choose any points in between here. So I think just for the sake of kind of, I guess, confirming this. So one of the points we had was, so we had wheat and computers. So I think this was what, 4,100, and then this was 2,500 and 250. So if we use those 2 points, wheat's on my y-axis. So change in y over change in x would be the change in the quantity of wheat that was on my y-axis over the change in the quantity of personal computers or computers here. So what's the change in my y moving between these 2 points? -1,500. What's the change in x? It was going up by 150. Sure enough, I get that same value of -10. Right? So it doesn't matter what 2 points I use on that curve, I'll always find it's a linear curve, right? At least for now, before we complicate it next class. But for now, it's just this nice linear curve. Any questions on this idea? Also, is this showing up as red or not really? No? Let me try something. So I had it working earlier. Now it looks like it's not showing up as red. So how can I do this? Color is on. You guys might have to help me. You see the colors here? A little bit. It's kind of washed out, isn't it? That better, worse? Well, can you kind of see it now? This is kind of red. So I'm trying to color code this. I'll have to play around with this. I don't know why it's so washed out. It usually is kind of set up all right, but hopefully, we've got all the information. So I'll try to color code it as best I can. Okay. Any questions on this idea before we keep? Okay. So we've got this table. All right. I drew kind of the graph that corresponded to it. And one thing that we noticed was whatever that slope is, now it's always going to be negative, but it tells me the cost of my x-axis good. Okay. So before I kind of keep going here, I'll kind of tell you and then I'll show you why this should be the case. But even if I drew the same depiction, if I wanted not just the cost of a computer, but I wanted the cost of the other goods, a ton of wheat, well, what would I have to do? Well, the slope tells me the cost of my x-axis good. What'll end up being true is 1 over that slope tells me the cost of my y-axis good. I'll show you why in a second that works, but for now, just believe me. Okay? So anytime we draw out this production possibilities curve, it's easy to find the cost of the x-axis good, which is change in y over change in x. If I want the cost of the y-axis good, I still find that slope, change in y over change in x, but I have to do 1 over that slope. Okay? So why does that work? Well, if we think about this example, where we already found the slope of our production possibilities curve, where computers were on my x-axis. Let's say instead, try to see how these colors are showing up here. Let's say instead I put wheat on my x-axis instead. So if I'm only producing wheat, how many total can I produce? 5,000. If I'm only producing computers, I could produce 500. So once again, what would the change in y be now? I'm going from 500 to 0. So I'm losing 500. What's the change in x? I'm going from 0 to 5,000. Sure enough, I get negative 1/10 or negative 0.1, which my original slope was negative 10. So it ends up being 1 over that slope of the original production possibilities per length. Now, if that's difficult, like to remember that it's 1 over, you can always just draw it out and put whatever good you want to find the cost of on your x-axis, right? The reason it works is because when you flip the axes, right, it's just an inverse. So whatever your slope was before, your new slope would be 1 over that. But once again, I think sometimes to make it easier, whatever you want to find the cost of, put that good on the x-axis and then kind of solve for that slope. Any questions on that idea? Good with that? Okay. So with that idea in mind, right, we'll now start to think about, okay, if we can understand the costs using this production possibilities curve to producing a good, we might want to compare across countries, right, or individuals. So I've got kind of a basic example here. So let's think about I have 2 individuals. I don't know. Let's say the CEO of Ford is like this, savant at fixing cars, and he can fix his own car in an hour, right? There's a mechanic who's not quite as good, right? He can do it with 3, right? So who is better at fixing this car? The CEO, right? But why might the CEO pay a mechanic to fix his car? Because his time is worth a lot. He's okay paying the mechanic $200 because every hour he has working as a CEO of Ford, how much money is he generating? A ton, right? And so his opportunity cost of fixing his own car is going to be really high, right? So just because someone can do something at a lower cost themselves, that's only if we don't factor in the opportunity cost. Right? We talked about last week. A lot of times, if we're just looking at like the explicit cost, maybe it looks like we should be doing one thing, but if you factor in the opportunity cost, it can change that decision. Same kind of idea here. So we don't actually just care about the cost. We care about who has a relatively lower cost, right? And not just cost, but opportunity cost, right? So if I think about the CEO, let's say their time is valued at $2,500 an hour. If they fix their own car, what was the cost to them? $2,500. If they don't fix their own car, they pay the mechanic. Well, how much money did they generate in that 1 hour? $2,500. How much did they pay the mechanic? So they're still better off by what, $2,300. It's way better for them to still pay the mechanic. Right? And that's because their opportunity cost of time is really high. Yeah.
So would it not 2,500 times 3 which is hope?
So, all right, the cost to the CEO would be if he chose to fix the car himself. So it would be just his opportunity cost of time, right? And then here, I think if I didn't state it, I meant that there was $200 just to pay the mechanic for there wasn't like $200 per hour. You could complicate it, make it $200 per hour, then the cost would be $600, $2,500 minus $600, still better off, right? Still $1,900 positive, pay the mechanic instead. Is that you're right? All right, so what this gets at is an idea that we'll start talking about. We're not just comparing a CEO and a mechanic, but if we're comparing across countries, basically who has this lower opportunity cost, okay? What we'll call this is we can have absolute and comparative advantages, okay? So absolute advantages are pretty easy, This is just using all of their resources, who can produce more of this specific good. So in our earlier example, let's say we had 24 hours in a day and we were going to let the mechanic and the CEO spend all their day fixing cars. How many cars could the CEO fix in a day? Well, if he can fix a car in an hour, it's 24 hours in a day, fix 24 cars. Mechanic, if it takes him 3 hours, he spends all day, how many cars could they fix? 24 over 3 or only 8. So who can fix more cars? CEO. So what we would say is that CEO has, using all of their resources, can fix more cars a day. They have an absolute advantage, right? In the context of countries we'll look at in a second, if a country uses all of its resources, they have an absolute advantage compared to another country if they can just produce more. Now, just because they can produce more does not mean they have what we call a comparative advantage. A comparative advantage says whatever we're producing, we can do it at a lower cost. Okay, so we'll kind of see how this relates to our production possibilities curve here in a second. But absolute advantage is just I can produce more using all my resources. Comparative advantage, I can produce more of this good at a lower cost. So I think I've got an example here instead, a little more applicable to like economy-wide production possibilities curves. So I had what? The US and India, and I chose what? Aircraft parts and iPhones. I don't know, for whatever reason, those are the two goods I chose, right? So usually you'll have this information depicted to you in like a little 2x2 table. So what this is saying is using all of their resources, if the US puts every resource they have to producing iPhones, they can produce 60. If they put all of their resources towards aircraft part production, they can produce 30. So it's not simultaneous, it's one or the other. This is the total amount they can produce using all of their resources going towards one of those goods. So really, what do we have information on here? So if I've got aircraft parts and iPhones, I think I'll have it set up here. Doesn't matter which way I choose. So I'll make the math easy to start. So if they're only producing iPhones, or if they're only producing aircraft parts. We just said if they're only producing iPhones, the US could produce 60. If they're only producing aircraft parts, they can produce 30. Okay? So their production possibilities curve looks something like this. Okay? Now, if I wanted to, what would the slope of their production possibilities curve tell me? The cost of whatever is on the x-axis. So the slope should tell me the cost of one aircraft part. Once again, how do I find the slope? Well, by moving between these 2 points, it's the change in y. So going from 60 to 0, right? So negative 60, change in x, I'm going from 0 to 30. So every aircraft part is going to cost, oops, sorry. I forgot my equal sign. Every aircraft part is going to cost the US 2 what? 2 of the other good, right? So every aircraft part is going to cost the US, or they're going to have to give up producing 2 iPhones. So that's their cost. Now, the other country, India, we'll go back to the table in a second, but this is where I'm going to get the information. It told me that if India is using all of its resources to produce iPhones, maybe they don't have as many people or they don't have as many companies available to do this, they're only getting 50. Okay? This is kind of showing up a little bit red now. Okay. And once again, I'll try to mess around with these settings to get this to be more pronounced. I don't think this light's going to help us. Does that feel like an eye doctor? 1 or 2? Which one's better? 1, space the same. Okay. And if you've never been to the eye doctor, that would probably just go right over your head. But if I'm only producing iPhones, India can produce 50. Where if they're only producing aircraft parts, I think I had the value was 10. So I tried to draw this to scale, but if I'm instead calculating the slope for India, what's the change in y? Going from 50 to 0, change in x, 0 to 10. Notice their production possibilities curve is a little bit steeper. If I have a steeper production possibilities curve, if the slope tells me the cost of the x-axis good, whoever has a steeper curve, that means their cost of the x-axis good is actually higher, right? So their cost is going to be higher to produce that x-axis good. So who do I want producing something? Whoever can produce it at the lowest cost. So here, when I compare the cost of these two countries, so if I think about cost of what? Whatever's on my x-axis, the cost of one more aircraft part to the US is 2 iPhones. The cost to India was 5 iPhones. So who has the lower cost? The US. So we would say that the US has a comparative advantage in the production of aircraft parts. They have a lower cost. Everybody with me on that idea before we throw in even more here? Okay. See where we're at on time. Okay, perfect. So that's my comparative advantage. An absolute advantage is if I'm using all of my resources, can I simply produce more? So here, who has an absolute advantage in aircraft part production? America, or the US, right? They can produce 30 compared to 10. Who has an absolute advantage in iPhone production? US as well. So when it comes to an absolute advantage, a country can have an absolute advantage in both goods. Or neither good, right? India doesn't have an absolute advantage neither. Now, it doesn't have to always be that way. So I'll just kind of show you an example real quick, and then we'll come back to this example. So let's say I had something like, instead, I don't know, we'll use the same two goods just to make this easier. So I have iPhones, aircraft part production. You know, I don't know, here's the US, we'll kind of keep that the same. Maybe we're comparing them to a different country that looks something like this. Well, in this example, and I don't know, let's say this is Canada, this is the US. Who would have an absolute advantage in iPhone production? Using all their resources, who can produce more? The US. Well, who has an absolute advantage in aircraft part production? Canada. So it doesn't always have to be that a country has an absolute advantage in both goods, right? They can only have, you know, an absolute advantage in one, both, or neither. Right? It's kind of depends. So really, when we're talking about an absolute advantage, what am I comparing? Simply the, what would you call where the line hits the y and x-axis? The intercepts, right? Absolute advantages I can determine from the intercept. Now, I can simply look at that table I had before and say, well, using all the resources, the US can produce more iPhones in India, and they can produce more aircraft parts. So you can use a table to get that information. But once again, most things we do in this class, you can draw out a graph that's going to help as well. And from that graph, what tells you who has an absolute advantage is just comparing those intercepts. Now, the comparative advantage is harder to get just from looking at this table, because there we need to compare the costs. So we would need to compare the slopes, which is what we did here, right? Who had the comparative advantage in the x-axis good? Whoever had essentially a flatter slope or the lower cost. Now, there's some rules of mathematics that we could use, but for the sake of this class, you can always draw this out, and some of you might be able to kind of see where I'm going before I even get there. So I said that the US has a comparative advantage in aircraft part production. If I wanted to know who has the comparative advantage instead in iPhone production, oops. Well, how do I get the costs of my y-axis good? We said it was simply the inverse, or 1 over the slope. So for the US, if their cost for an aircraft part is 2 iPhones, their cost of 1 iPhone would be what? 1 over 2, right? And then for India, so I should be clear here, every iPhone, they'd have to give up half an aircraft part, right? The cost of a good is always in terms of the other good. Now, India, if their cost to an aircraft part was 5 iPhones, then the cost of one iPhone would be 1 over that slope, or 1/5 of an aircraft. So sometimes fractions are hard. This is 0.2. This is 0.5. Who has the lower cost to producing one iPhone? 0.2 is less than 0.5. So who has a comparative advantage in iPhone production? India, right? Because you're doing the inverse, anytime you have a number that's greater than another number, when you do the inverse, that sign flips, right? So for example, here, we had that 2 is less than 5. Once we take the inverse of those two numbers, what happens is this sign will always flip. You could go through the mathematical proof if we really wanted to, or we could just kind of prove it to ourselves using the actual numbers. Right? So you can only ever have a comparative advantage when we're looking at these simple 2 good models, which is all we'll do. You could do 3 goods. In fact, then you get like a 3-dimensional graph. And then it gets just a little complicated. Then we can do matrix algebra. You have 5 or 6 or 7. We're not going to do that, right? We're going to keep these at our simple 2 good models. The same logic would apply no matter how many goods we're adding. So here I can only ever have a comparative advantage in one of these 2 goods. Okay? Yeah. To a question. Oh, sorry. So we can only ever have a comparative advantage in one of these goods. Because as soon as we use that inverse, it makes it so that my cost of the other good, if it was higher before, now I have the lower cost, or vice versa. Okay? And if it helps, you can always work out the math. You don't have to just remember that, right? You can find the cost of the y-axis good by doing 1 over the slope and then proving to yourself, oh yeah, the other country, the US has a lower cost to the x-axis good. India has to have the lower cost then to the y-axis. Any questions on this idea before we keep? Okay. Let's see. Oh, I think I've probably already mentioned this. We talked through the absolute, and this is sometimes where I'll do a bunch of work on the dot can, and then maybe I have some reminders in the slide. Now here, I did the exact same thing, but I flipped it. What good did I put on the x-axis here? Not aircraft parts, but iPhones. Now, hopefully, if I did everything correct here, we'll get the same answers. So even if I drew it out the other way, who has an absolute advantage in iPhone production? The US. Who has an absolute advantage in aircraft part production? US. So intercept for both goods is higher. Now, if I put iPhones on my x-axis, what does the slope tell me? The cost of the x-axis good. So if I calculate these slopes, I get that US, every iPhone costs them, what, 30 over 60, or half of an aircraft part. And that India, every iPhone costs them 10 over 5, or 1/5 of an aircraft. It's exactly what we found when we set up the other way and then did the inverse. Right? So it doesn't matter which way we set it up, we'll end up finding those same values. Now here, if I was specifically just interested in the cost of an iPhone, it helps to start out putting that on my x-axis, right? But it doesn't matter, because now that I have the cost of these iPhones, how would I find the cost of my y-axis good for aircraft parts? Simply do 1 over the slope. So what would the cost of an aircraft part be for the US? 1 over 0.5. And for India, it would be 1 over 0.2. Should I enter those in my calculator? What do I have here? I get those same values of 2 and 5. So it doesn't matter which way I set it up, I can always get the cost of both goods for both countries. And then once again, if I want to make my decisions, we already talked about the absolute advantage. But if I'm just comparing costs, who has the comparative advantage in our iPhone production? Who has the lower cost? India. You get the same result as before. And then once I find the cost of my new y-axis good aircraft parts, who has the lower cost? Same value, so the US. We found the exact same thing if we kind of flip which goods we put in the x and y axis. So that's good news in that, like, it doesn't matter. It doesn't matter which way I start drawing it out, I can still find the exact same values and the exact same answers about who has an absolute and comparative advantage. Is that questions on that? So this is where I think drawing it out helps a lot, right? And if you really want to, you could always, if you're just like kind of confused by this whole idea, if I want to know who has a comparative advantage in something, I want to know who has the lower cost. So if I want to know who has a comparative advantage in iPhone production, how do I come up with the cost of an iPhone? I put it on the x-axis. Slope tells me the cost of that good. So I can put iPhones on my x-axis, determine the costs, and figure out, okay, India has the lower cost. Instead of doing all this one over the slope business, if I then say, okay, who has a comparative advantage? First of all, I already told you, if one country has an comparative advantage in one good, the other country automatically has to have a comparative advantage in the other good. But even if I couldn't quite remember that, if I want to know who has a comparative advantage, I want to know who has the lower cost. So who has a comparative advantage in aircraft part production? What good would I put on my x-axis? Aircraft parts. If I did it that way, I come up with my costs. Now I can figure out, sure enough, US has a lower cost or a comparative advantage in that. So there's kind of multiple ways of doing this. Some of them probably take a little more time if I can't remember this idea that you can only have a comparative advantage in one good. That's the easiest, because then once I find who has comparative advantage in one good, I automatically know the other person or the other country has a comparative advantage in the other good. But I can always work out these models, work out the math to determine that as well. All right. So kind of got this set up. We're thinking about the cost of these two goods. So I'm going to kind of ask you guys to do a little bit of work yourself. So I've got this here. This is where got this in-class quiz. So I'm going to publish this, right? Let's see. I don't know if I have a number. I don't think I set a number here today. If I did, figure out what it is. Okay, so I didn't put an access code on this today. I'm actually going to be kind of nice today. I mean, your school only wins a national championship probably once in what? It's what, 120 years or something like that. So I understood a lot of people are probably missing today. So today's, I'll help, there's still an advantage being here in class. We'll walk through the answers here. I'll likely edit this video to cut this part out for work in class. They'll still have the quiz available to them until the end of the day, just to be a little bit fair. But for that showed up, there should be value added. So we'll kind of work through these together. Okay. So in fact, it's going to help me